Exercise 5.3, question number 2. In exercise 5.3, you have to evaluate the improper integrals and you have to tell whether these improper integrals converge or diverge. For that purpose, in the previous video part, I have mentioned you some of the definitions that you have to follow while attempting this exercise 5.3. So consult exercise 5.3 part 1, understand that definitions, and then come on the second part for this exercise. So question number 2 is, integrate 0 to infinity e raised to power minus x sine of x dx. This will be equals to limit t approaches to infinity 0 to, now replace your infinity with t, e raised to power minus x sine of x dx. Mark this as equation number 1. This is not a simple function. If that was a simple function, then I will integrate it here like I solved it in question number 1. I just took this function as it is with this limit and solved it in the same pattern. But here I am not following that pattern, because here you have a complicated function. First integrated by parts, then put the value here and use the limits of integration, and then at the end apply this limit. So I am separately first of all solving this integral. So consider this simple integration e raised to power minus x sine of x dx. I will take its answer and then I will apply this limit on it, and then after getting the answer put it in equation number 1. That will be easy. So this will give me, let it equals to I. So I will be equals to, this is first function and this is second function. First function into integration of second function minus integral derivative of first function into integration of second function dx. This will be I equals to minus e raised to power minus x cos of x minus integral e raised to power minus x cos of x dx. So I will be equals to minus e raised to power minus x cos of x minus. Now I am taking again it as first function and this one as the second function. Use the brackets. First function into integration of second function minus integral derivative of first function into integration of second function dx. This will become I equals minus e raised to power minus x cos of x minus e raised to power minus x sine of x minus minus plus, and this will minus integral e raised to power minus x sine of x dx. If you observe, this is the same integral I. Move it on the left side. I plus I will give you 2i here. This will become minus e raised to power minus x cos of x minus e raised to power minus x sine of x. So this term will become I equals to minus e raised to power minus x by 2, and inside cos of x plus sine of x. Now you can use its answer here in this one. So this one will become, using above answer in equation number 1, we will get 0 to infinity e raised to power minus x sine of x dx will be equals to limit t approaches to infinity. Now you see here we have limits of integration as well. So write that function and first apply the limits of integration on it. That is from 0 to t. First of all, we need to apply the limits of integration. This will be equals to limit t approaches to infinity. After applying the limit of integration here, and you know that very well, I also solved the definite integral exercise in the 4th chapter as well. So it will be not difficult for you now to apply this limit. First of all, apply the upper limit, then minus lower limit. This answer will come here like e raised to power minus t sine of t plus cos of t divided by 2 plus 1 by 2 here. After applying the upper limit, minus same function with the lower limit. Now apply this limit here. You observe that this e raised to power minus t, if we apply the limit of integration, this limit here, this will become e raised to power minus infinity, that is equals to 1 over e raised to power infinity, that is 0. So this term will make this whole term as 0. So you will get here 0 plus 1 by 2. So the answer will be 1 by 2. So it converges. This implies that is question of this integral converges. Now come on, question number 3. Minus infinity to 0 dx over 1 plus x square. This will be equals to limit t approaches to, now this one is undefined, so t approaches to negative infinity, and replace that with t to 0 dx over 1 plus x square, like this. Now this is a simple integration, so I am solving it as it is here with it. Whenever you will get some complicated function like this, you need to just separately solve it, then use the answer here in this equation number 1. So I am solving it here as it is. It will be limit t approaches to minus infinity, and you know that integration of 1 over 1 plus x square is tangent inverse of x, and the limits of integration are from t to 0. Now this will, after applying the limits of integration, you will get here limit t approaches to minus infinity. Here you will get tangent inverse of 0 minus tangent inverse of t, upper limit minus lower limit. This will become limit t approaches to minus infinity, this term will goes to 0, and you will be left with only minus tangent inverse of t. So this term will become equals to minus limit tangent t approaches to minus infinity on tangent inverse of t. And if we apply the tangent inverse of minus infinity, tangent inverse of minus infinity is minus pi by 2. You know that the asymptotes of tangent graph, the tangent becomes undefined on pi by 2. This is negative infinity, so you will get negative pi by 2. So here it is pi by 2. So the given improper integral converges because you got some defined answer here. Now this term will become equals to 0 to infinity e raised to power minus 2x cos 2x dx, and this term will becomes equals to limit t approaches to this undefined term 0 to now t e raised to power minus 2x cos of 2x dx. Now we need to integrate this function, and for integrating that function, you know very well its answer. Its answer, this integral e raised to power minus 2x cos 2x. For solving this integral, you have to consult example number 13, that is given on page number 140. Just consult that example. You can solve it using that example and get the answer. Get that answer and put it here. So I will be left with, this is equation number 1. You will separately solve it and you will get the answer e raised to power minus 2x cos of 2x dx will be equals to e raised to power minus 2x over 8 minus 2 times cos 2x plus 2 sine 2x, this answer you will get. Using above answer in equation number 1, we will get 0 to infinity e raised to power minus 2x cos 2x dx, that will be equals to limit t approaches to infinity. Now this answer e raised to power minus 2x over 8 times minus 2 cos 2x plus 2 sine of 2x, and the limits of integration are from 0 to t, this one. Now apply the limit, we'll get limit t approaches to infinity. Use the upper limit first. You will get e raised to power minus 2t over 8 minus 2 cos 2t plus 2 sine of 2t minus, formula minus, use the lower limit now. After using the lower limit here, you will get e raised to power 2 times 0 will give you 0 over 8, and here minus 2 times cos of 0. Cos of 0 will give you 1. So 1 into minus 2 will give you minus 2. Plus 2 sine of 0 will be 0 here. So you will get here limit t approaches to infinity, e raised to power minus 2t over 8 into minus 2 cos of 2t plus 2 sine of 2t. Now this term goes to 1. 2 and 2 will be cancelled out. 2 with 8 will be cancelled out. You will be left with here 1 over 4. Now apply the limit here. Due to this function, this will be e raised to power minus infinity. This will become 1 over e raised to power infinity goes to 0. So due to this 0, the whole term goes to 0 if you put the limit here. So you will get at the answer at the end 1 over 4 here. So it converges. So question number 4 integral converges to 1 by 4. This is equals to limit t approaches to minus infinity, this undefined term, and replace this undefined with t, 0. This will become 1 over 2x minus 1 whole cube dx. Now you know that how to integrate this function. This will be limit t approaches to minus infinity, t to 0. We can also write it 2x minus 1 minus 3. Now we can make its derivative here. How? Just divide it with 2 and multiply it with 2 dx. So its integration will be limit t approaches to minus infinity 1 over 2. Now its integration will be power plus 1 divided by that power. 2x minus 1 minus 3 plus 1 divided by minus 3 plus 1, and limits of integration are from t to 0. So after simplification, we will get here limit t approaches to infinity, and we will be left with minus 1 over 4 times 2x minus 1 whole square, and limits of integration are from t to 0. This we will have here minus 2 and 2 will give you 4, and this negative sign I have written upside. Now use this upper limit and the lower limit. You will get here limit t approaches to infinity, this is minus infinity. Now minus 1 over 4 times upper limit, 2 times 0 will be 0. So you will get here 0 minus 1 whole square. Then negative sign of formula, negative will give you plus 1 over 4 into 2t minus 1 whole square, like this. Now apply the limit here. If we apply the limit here, this 1 over infinity will goes to 0. So we will be left with only this term. So from here I will get minus 1 over 4. So it means it converges. So this is the answer for our question number 5. This will becomes equals to limit t approaches to this undefined, and replace this undefined term with t, e raised to power 2x dx. This will be simply equals to limit t approaches to minus infinity, and you know that how to integrate it. This will be e raised to power 2x over 2, and the limits of integration are from t to 2. So this term will become equals to limit t approaches to infinity. After applying the limit here, you will get e raised to power 4 over 2 minus e raised to power 2t over 2. Apply the upper limit minus, then put the lower limit. Now use this infinity term here. After using this term here, this is negative infinity. This negative infinity will make you this term 0. So you will be left with e raised to power 4 over 2. So this means it converges. Now this is the other definition that I told you, that I discussed you in part 1. If we have some integration, limits of integration from negative infinity to infinity, then we need to break our integral into two parts, from negative infinity to 0 and 0 to infinity. So this will become negative infinity to 0, the same function, plus 0 to positive infinity, the same function, like this. Now this term will become limit t approaches to negative infinity. Now replace this negative infinity with t and upper 0, dx over 1 plus x square, plus limit t approaches to infinity and replace that infinity with t dx over 1 plus x square. So this thing will become now limit t approaches to negative infinity. You know that we just solved question number 3, that was limit t approaches to negative infinity from t to 0 dx over 1 plus x square. This thing gave us the answer pi by 2. So I can replace this whole term with pi by 2. I am replacing the whole answer with this pi by 2. Now I need to solve this one. For that purpose, just use the same method for question number 3. We'll get here, you will use here plus infinity. So this term will give you here plus pi by 2. And plus this term will become, let me solve it as well, limit t approaches to infinity. This term will give us tangent inverse of x from 0 to t. So this will becomes equals to pi by 2 plus limit t approaches to infinity. This will become tangent inverse of t minus tangent inverse of 0. This term goes to 0. Now apply the limit here. This term will become, after putting the infinity here, tangent inverse of infinity will give you pi by 2. So the answer will be pi. So it means it converges. The given integral converges. So this is the answer for your question number 7.